Software Engineering Radio, Episode 53, Product Line Engineering, Part 1. Welcome to Software Engineering Radio. In this episode, Michael and myself, Markus, will discuss product line engineering and software product lines in general. So, Michael, I think you will start, I guess.
You should listen to this episode when you don't develop one-off products, but multiple products in the same domain, so related products or similar products.
So what could be some of the examples of related or similar products, so our listeners can relate to what you mean?
So, for example, when you build a car infotainment system, you are typically driven by the automobile vendors as a delivery company, delivering the infotainment system to that company. And so BMW has very distinct requirements on the feature set and the GUI and everything of the entertainment system than, for example, Audi has. And you as a vendor of infotainment systems, you have to deal with that, basically have to deal with those variations in requirements, and you cannot afford to build the products, the infotainment systems every time from scratch, but you have to reuse your artifacts, and that is exactly one of the core topics, the reuse. How do you organize the reuse in your development to reduce your development cost?
Yeah, I think another example of product line development could be mobile phones. If you take a look at today's mobile phones, where you get a new phone every 3 weeks, then those phones are really just incremental developments over the previous phones. So if you have a product line that helps you come up with new software releases, new combinations of features, the one with camera, the other one without camera and stuff, then having product lines will increase your productivity. So this is again a situation where product lines are often used.
A good indicator whether your domain actually needs a product line or not is looking at the development. When people already started building platforms to foster reuse, it is a good sign that you are actually developing a product line.
So what are some of the reasons why you would like to do product lines? I think one primary reason is probably that the efficiency of development is going to be higher. So you're going to be cheaper and faster and better probably in building new variations of your system or new products in your product line.
Yeah, as we already discussed, there's the topic of reuse. And whenever you have the feeling that you could do better by reusing artifacts from one product development to the next product development, that is a good sign. And so people start typically developing platforms, and the platform then contains all the common artifacts plus very often many generic artifacts, because, well, you typically want to prepare yourself for all kind of variations, potential variations that you might not even know today. And so the second, for me, one of the key reasons to switch to software product line development instead of just platform development is the drama of platform development. Who doesn't know about the situations when you develop the platform, 2 years later the complexity of the platform just grew out of every range. You're not able to manage the platform anymore. Everybody just bashes about a platform. Well, we need to build a new platform with this new technology, and the old technology just is not sufficient anymore. And at the end, you then have trouble hitting the market with your products because you're so stuck in all those platform development, and you never really get to the actual products to develop the products. And so these are some of the key indicators that you actually do something wrong, or maybe your paradigm that you're developing in is not sufficient.
So what then is the key difference between developing a platform which you want to reuse and product line development?
Well, software product line engineering provides you with a frame for the development of your platform. You still have a platform. And actually, looking at some of the definitions of software product line engineering, it is defined as developing on the basis of platforms. So it's platform development and mass customization. And here the mass customization brings in all those variability, this flexibility that you need, that this derivation of individual products from that platform.
So mass customization means that instead of actually creatively building a product, which is a member of the family or of the product line, you rather take some configuration language, a configuration tool, some means of specifying the features you need for your product. Then you press a couple of buttons and the configured, customized product falls out of the end of the product line? Or?
Yeah, that is kind of the idealistic view. But in general, every method, every tool, every concept is fine as long as it helps to increase the level of abstraction. That is the key thing. And so here model-driven development or generic approaches help. But another key thing is that you explicitly deal with variability. And you do that at all phases, at all times, and you remove variability. And that is one of the key factors I see why platforms become outdated and just die, because nobody really looks at the variability they support, and nobody dares to remove any variability that is no longer needed.
Okay, so before we explain some of the more detailed topics like variability management and then some model-driven aspects, I think I'd like to point out that product line development increases the efficiency and reduces cost in a long-term view. So it's not something that will help you. If you have the problem today, it's probably not going to help you today. It's something. It's a strategic thing that you have to do when you do product line engineering. Yes,
it's something totally inconvenient, I would say. It's something that you must have felt enough pain to switch to. Unless you felt the pain and you maybe lost your market shares and you had real trouble with your development, you're most probably not going to switch to a software product line engineering approach, because it just requires too much effort, too much upfront investment, too much discipline of all stuff. I mean, when we later discuss feature modeling, when we later discuss configuration management, product derivation, it's all really complicated and tedious stuff, but it helps you at the end to reduce the cost of development.
Okay, so some of the drivers are if you have to have developed products for different platforms, if you have rapid changes on the marketplace, you have to you have to deliver products in short iterations, and maybe if you have related, similar but not identical products in a certain domain, these are the key drivers why you would want to go to product line engineering.
Yeah, but also the domain itself should stay stable. If the domain is changing that you're developing the products for, it's hard to keep track, and the upfront investment might be lost again.
Yeah, so you say if you develop automotive and infotainment systems today, mobile phones tomorrow, and insurance enterprise systems in a week, then this is probably, it doesn't pay off to invest in a certain product line if your domain changes all over.
Yeah, if the domain changes that dramatically, but even smaller changes in the domain, like shifting from a focus from, for example, navigation systems to then pure entertainment systems to pure MP3 players or so, this might be already enough of a change to endanger your platform, your product line investments.
So that's probably the reason why maybe the first step in product line engineering is what some people call domain scoping. Which tries to suggest that you have to define where your domain begins and where it ends. And probably the more narrow you define your domain, the easier it is to come up with a good, workable and pragmatic platform.
Yes, scoping is very important to limit the investment, to really get focused, and well, of course, focusing is always good, but it really has an impact on the business case. The business case is something maybe when I talk to the SEI people, Software Engineering Institute people who are leading the research community in software product line engineering, when I talk to them, they say the business case is the most important thing. So I as an engineer don't like to think about business cases, but somebody in your organization should really think about a business case, whether it's actually worthwhile to invest in a platform, to invest in a product line, or just do one-off development for every customer request. So keep that in mind. The business case is important, but now we talk about the other stuff.
Okay, so I think we should start or continue actually by explaining a couple of key concepts. One is project development versus one-off system development versus product line development.
Yeah, in our company where I work for, we typically have system development or we have product development. Product development means that the feature set you deliver to individual customers is always or almost the same, that you don't have really shrink-wrapped software in our company, but we have products that are as they are. There's a little customization, but the customization is mostly configuration, and so it's not a big deal, and it's not a key development effort to customize the solution to a specific customer. Still, it's very hard because every customer has, of course, wishes that he tries to bring into your product, and the different roles in your organization, for example, sales and development, always struggle and fight on which internals to change for this specific customer and which things to keep the development smooth and easy. System development on the other side, that is or system or solution development. Here you fully adopt the changes, the individual customer requests, and you basically do a one-off development for this single customer. You do a solution instead of a product, and this has the problems that, of course, the customer requires you to maintain the solution, and he also wants to benefit of all the new features, and you basically have to develop all the new features for all branches in your configuration management, where you typically keep the solutions for all individual solutions that you ever build. You have to deliver potentially this new feature, and so you have a huge effort to bring in those new features. And well, a typical approach is to use platforms for this, but that's just not sufficient to deal with all the changes, to deal with the variability. You need to have a strong variability management, so to say.
So what you say is that product line engineering and the techniques we're going to talk about in these and in subsequent episodes are important for product as well as for system development.
Right. Both disciplines, both kind of businesses heavily benefit from adopting a software product line approach.
Okay, and maybe to care about some of the more enterprise-related terminology where people talk about projects, where you go to a customer or where some customer comes to you as a consulting firm and says, hey, develop me the system of whatever, J2EE. This is basically system development. It's also a one-off system. Of course, if your company builds, insurance systems all over again, then you might want to adopt a product line approach internally to be able to deliver to your customer insurance applications faster. The customer need not necessarily know that you're actually using product line techniques.
Yeah. Two other terms that we now used already in our conversation were product line and product family. And the term product line, well, can also be used and is often be used to identify products that are in the same portfolio of a vendor, but not necessarily have any assets in common. They are not constructed or made of the same artifacts, whereas the term product family means today the same in the product line engineering community, but has a stronger hint on the commonality or on the common ancestors of the common core assets that the product was built from.
I've read a definition of software system family or product family, which says basically that a set of products is a product family if it's worthwhile to look at the commonalities between the products before you look at the specific differences.
Isn't that by Parnas or so?
Might be, I don't know, somewhere in my slides. I don't know where I copied it from. Okay, to illustrate the other thing, the non-technical product line, if you go to IBM, you'll see that they have a whole range of WebSphere products. They have the WebSphere application developer, they have WebSphere application server, they have WebSphere every place, I think, and they have WebSphere MQ. The first one is an Eclipse-based development environment. The second is a J2E application server. Number 3 is an OSGI implementation. And number 4 is MQ series rebranded. And obviously, since these are completely different systems for completely different technical domains, they certainly have no common code. I'm not an IBMer, so I don't know, but I would also based on their history, I don't think there is any common code. However, they're all part of the WebSphere product line, and that's clearly a marketing term or it wants to suggest some things that work together or whatever. So that's not what we talk about. We talk about products that have technical similarities. They're built on a common platform, and where, as we'll see, variabilities between the products are managed explicitly.
Yeah, in this episode we talk about software product lines, but there is also the term product line in general, so not only focusing on software but on hardware, electronics and software. And so this is actually a true research topic, combining all the different disciplines of hardware and software, and it's truly challenging to build systems with a product line where both disciplines, hardware and software, are involved. But for this episode and this, we focus on software product lines.
Although, as you said, most product lines are in the context of embedded systems, and most of them have some hardware aspect to it. And just to mention that's one of the reasons why the OMG started the SysML modeling language, which is basically a UML dialect that can be used also for systems modeling, so it includes hardware. But that's a different topic. You might have to talk to Tim Wilkins, I guess.
Two other, for me, very important terms to get the rest of the terminology straight is the understanding of a problem and a solution space. This goes back to the book by Krzysztof Czarnecki, Generic Programming, where he drew...
Generative Programming,
where he drew some diagrams where he separated the problem and solution space. And so I like this analogy very much and like to use it for explaining product lines. And so the problem space, here you talk about the requirements, the use cases, ideally even scenarios and non-functional requirements. And at the highest level of abstraction, and for what's really important for product lines, you talk about domain modeling. Here I would just refer to the interview with Eric Evans in our podcast. And in the solution space, you talk about, well, at the lowest level of abstraction, all the API calls, all the source code, but also about the architecture, the frameworks that you potentially use, and in a software product line, most probably also configurable components. You talk then about your DSL, the domain-specific language, which you might use to configure your system to instantiate it.
And of course I have to comment on this one, since this is very much model-driven development stuff. So the idea of the solution and the problem space is obviously very related to what we talked about in model-driven development, where you have the models that represent the problem space, then you have some transformation, which transforms the variability or whatever else you described in your model into implementation structures, which is the solution space. And I think one thing is really important to understand. In the context of product line engineering, people often talk about configuration. So one reason for using domain-specific languages in product line engineering is to describe the configuration of the product using terms defined in the problem space, and then you have transformations that kind of find out how your solution space structure has to look like in order to realize the configuration described via the DSL. So in this context, DSLs are configuration languages. However, if you look at the more, traditional look at model-driven development, if you design, for example, the component structure of a system, then you probably wouldn't call this configuration, because you creatively compose a system from atomic building blocks, in this case components. So the important thing here is that there is a continuum for modeling languages or for domain-specific languages. In the simplest case, your language is just, a 5-tuple of booleans, right? So you can specify, I need this feature, I need this feature, I don't need that one, and I don't need that one. So the whole configuration is just basically tagging 5 checkboxes or checking 5 checkboxes. On the other extreme, the configuration language can actually be used to configure complex frameworks, and you can actually draw diagrams and you draw graphs or use complex textual modeling notations to really describe complex configuration data structures. And in that case, people don't call it configuration anymore. People typically call this programming with the DSL. And so this continuum between configuration on the one hand side and, as Krzysztof Czarnecki called it once, creative construction on the other side. These are really two extremes of a continuum, and your language can be used for all intermediate steps. And we'll talk about some of these details in later episodes. But I think it's important to mention.
Yeah, you mentioned already an important other term, that is feature and feature modeling. And feature models represent the variability and the commonality in your problem space using features. And for individual features, you typically have a keyword or a combination of keywords by which you identify a certain feature, and you organize that hierarchically, so you to keep an overview. And typically such a feature model is used in for deriving later the checkboxes on which you specify your configuration, because on every variation point you have to make selections whether to choose a feature or not, or select alternatives, etc.
So there is relationships between the features. Things like, if you have that feature, you cannot have this feature also. Or if you have this feature, you have to choose one of the following 3 other features in order to make this definition complete.
Yeah, besides the hierarchy,
yes.
Besides the hierarchical structure, you also have relations among the features with constraints and recommendations. If you select this feature, you have or you should use also this other feature because this makes sense or is required.
To make this a bit more understandable, I'd like to just briefly mention an example. Consider the concept aeroplane. It has a feature wing. There is no aeroplane without a wing, right? So this is a recommended feature that every member of the product line aeroplane has to have. However, you can have a wing that is low, one that is high, and then one is that's on your shoulder. So you have 3 different arrangements of wings. So if you build an airplane, you have to have the feature wing, and then you have to select one of the following 3 sub features, which would be high wing, shoulder wing, or low wing. And there are other things. For example, there is an optional feature for airplanes, which is the engine. If your airplane doesn't have an engine, it's still an airplane. It's a sailplane, right? So, but if you select the feature engine, then you have to also select what kind of engine you have, which is typically either a piston engine or a jet engine turbine. So you have to select one of these two. So a feature model basically describes a kind of grammar, a set of constraints that you have to follow when you select the specific combinations of features for your specific product. So you can then basically take a suitable tool, we might want to talk about some in the future, in future episodes, where you just click, I want to have an engine, and then the tool says, okay, but then you also have to decide which kind of engine. So a feature model helps you come up with a correct configuration of features that will result in a workable and useful product.
Then next, I would like to discuss the term platform. We used it already, but in the context of software product lines, it's important to have a clear view on what a platform is all about. And in this context, a platform is not the set of libraries that you use to derive your products from. It is much more. Well, it might be the libraries, it might be the software assets, it might be all the software components that you have, of course, but then it's also the test scripts, the requirements, the feature models, the domain model especially. It's
DSLs, the generators, the frameworks.
It's all the core assets, which is just another term very often used in the community. It's all the core assets that you use to derive your concrete products applications from. And there are two kind of views on the platform. One is with a minimalist approach, saying you put everything in the platform that is common to all products, or a maximalist approach, you put everything in the platform that is common, and you put everything in that is variable, that is somehow used to derive one of the products. It's still contained in the platform.
But then how is the product configuration process different? If you have a minimalist approach, that means you have to add application-specific stuff. Yes. As opposed to having a maximalist approach, then you would just remove stuff you don't need, or you might configure it out at runtime or whatever.
Yes, exactly.
So which one is preferable? Or is it a question of non-functional requirements, like in the embedded space where you don't have enough space to carry around all the baggage of a maximalist platform? You might have a minimalist and add stuff.
Well, I guess, I've seen projects succeed with either approach, but personally I prefer to have a minimalist approach, say that is my platform, and the rest are just assets that I carry around. I don't call it platform because it's often confused with the maximalist approach, but I keep those things around in configuration management to later derive my products from.
Right. Yeah, that's the way I do it too, since I'm more in this model-driven world. I always have a platform of reusable generic frameworks and components, and then I use the DSLs to configure them or to add specific application-specific stuff on top of it.
But here we are at a point where it's crucial how you do the configuration management, how you do the product derivation, whether you keep derived products in your configuration management or whether you only keep the core assets in the configuration management, do the derivation, and just describe the rules how you derive the concrete product from it. So the concrete product is not instantiated and stored in configuration management. It's just the rules that are stored. But that is a whole big other topic.
But that hints to something we discussed briefly in when we prepared this episode, and that is that product line engineering is especially interesting if you have to keep a number of those different products valid over a long time. If you, for example, if you're building engine controllers for 4, 6, and 8 cylinder engines with 1, 2, 4, and 6 liters of Hubraum combustion volume, I don't know, cubic centimeters. You car freaks know what I'm talking about. I don't know. So if you have to be able to keep all those current and reproducible at the same time, then product line engineering, that's another reason for doing it. If you just, develop version 1 of a product today and tomorrow you develop version 2 and don't care about version 1 anymore, then that might not be such a, powerful reason to make you go product line.
Yeah, the next thing is variability. And we talked about it already. Variability is a key element in software product line engineering. And you have variability in the feature model, but you also have variability then, of course, in the implementation. And you need to link basically the solution space variability, the variation points, that is the points, the locations in the source code, the locations in your generator, in your model.
That's the solution space.
That's the solution space. With the problem space, where you do the selections or where you draw your DSL model. And so the means to implement variability in the solution space is, in my opinion, pretty well known. Besides the trend in model-driven software development, where there's still research in some areas, but the classical approach, having a strategy, for example, for implementing some runtime variability, or having macros in C, C++, or having templates in C++ to have a certain variability, and then this is pretty well known. Important in the context of the solution space variability and implementation variability is the binding time. When do you want to bind this variability?
So binding means decide about
And not make it changeable anymore. You can do it at runtime. Of course, at runtime you might be able to change it, but you can also think of binding time at instantiation, or even compile or link time when you do certain configurations binding of your variability.
So and the reasons of choosing one over the other are typically non-functional. So, if you want to be able to change stuff at runtime while the product is running at your customer, then it's not good to use an early binding time for your variabilities, because you can't change them at runtime anymore. However, if you do it at runtime, things are typically slower, and you have to carry around more baggage. So, just as a comment, although Michael said that these variability implementation mechanisms are pretty well known, we'll still have an episode on them and also show some of the not so very well known means of handling variabilities, such as aspect orientation and meta programming. So we'll cover this in more detail in future episodes. So what you say then in the end is that assume you have a platform and a set of libraries, a set of primitive building blocks that provide the respective variabilities. The challenge of product lines is to formally describe the mapping from the solution space variability, from the problem space variability down to the solution space variability. Yes. That's what Eisenegger and Czarnecki called, I think, the production plan or something like that, or the production knowledge in generative programming. And of course, being a model-driven guy, I'd say that one of the ways for doing that, not the only one, but one of the ways is actually using transformations as model-driven development advertises to do so.
Yeah, and I just had a conversation at the Software Product Lines conference about whether a DSL is already in the problem or in the solution space. And
it can be in either.
I would say it's for me, it's always in the solution space. The domain model, the knowledge, the entities described, they are in the problem space, and the generator, at least the generator, and that is for me the core part of the DSL, that is in the solution space.
No. So, okay, my terminology maybe is different. The DSL is the language with which you describe your models. And whether this is part of the problem space or the solution space depends on what you describe with your models. For example, you can easily say that you describe the configuration of some system in the problem space using a suitable DSL, and then you use a model-to-model transformation that generates another model which contains things like, components, message queues and stuff, which would be the solution space. But that can still be described with a DSL. It's just a different DSL, a DSL that has a different meta model and therefore describes different things.
But I put already in some brain, and that is for me the key differentiation. Of course, I did put, I also put in some brain and thoughts and work into deriving a feature model in the in the problem space, I put in some thoughts into developing the domain model. But as soon as I start with transformations, I feel this is already a step towards the solution, towards the solution space.
Absolutely. I agree that the transformation part is the way your transformations look like. They are obviously related to the solution space. Otherwise, you couldn't write the transformation. So if you consider typically what a code generator typically does is first you have the model as an input, then you validate the model against some domain-specific constraints. In case of feature models, it's just the semantics of the feature model below. In case of other DSLs, it's some other constraints that you define as part of the meta model. Once these constraint checks validate and there are no errors in there, and all this happens, that's all problem space. There is nothing about what you transform it to yet. Then the next step is the transformation or the generation. That is obviously specific to the solution space. So even if you have several solution spaces, several target platforms, then you have the same model in the DSL, you have the same constraints, and then you have several transformations, one for each solution space, one for each target platform, one for each whatever you call this. So, and that's why I would say that the transformation, the code generation aspect is definitely part of the solution space. However, the model from which you generate and the constraints against which you validate the model, that can be problem space, depending on the abstraction level of whatever you model with your DSL. And since the L in DSL stands for language, I tend to see this on the left side, right? The DSL for me is the syntax, the meta model, and the constraints, whereas the back-end part is not the DSL, that's the infrastructure to transform DSL models into something that's executable. But again, that's just my view, but I had to say it.
Okay. I mean, it's okay with me to if you see it that way, and I can understand this view. Though my last argument is that even a customer should then be able to come up with this DSL, with this language, and so this is my measure. Everything in the problem space, a customer should be able. A customer who's not an IT specialist in software engineering, should come up with the problem space artifacts.
Yeah, he should be able to come up with the notions, the meta model, whatever you want to describe, maybe a nice syntax by doing some sketches. The customer might not be able to come up with the tooling to build the models.
My customers weren't able to come up with a meta model yet.
No, but some kind of ontology that describes the terms that are important in the relationships, and then you as a IT guy, you take that and formalize that into a meta model.
Okay,
and then the tool battle begins.
And I see already the formalization step moving that into the solution space.
But what does this have to do with a solution space? I can conceptualize a problem space and define a meta model that is absolutely unrelated to any implementation stuff.
Okay, this is the fine border where we are.
Okay, so I think
we leave it there.
We have to fight this out at some. Okay, so maybe we cut this out, maybe not. Anyway, so where were we?
We were at explaining the variability, especially in the solution space, and I think we were so far through with the core terms. Maybe something related is the term or the concept of software factories. Software factories is an initiative and a methodology defined by some Microsoft guys, Jack Greenfield and Keith Short.
Yeah, and Stuart Kent and some others, Steve Cook.
And they basically made use of the software product line engineering know-how and the methodology and the concepts, and enriched it with what they call guidance and context. And they separated out model-driven development as a separate principle or technique to use, but I actually would have seen model-driven development as part of software product line engineering. What's very common to use for product line engineering.
It's a common implementation technique for product line engineering, but it can be used outside of product lines.
Right. So that is a related topic, and maybe we have some interview or some somebody talk about that later. We'll see.
Trying to get Krzysztof Czarnecki in front of the mic.
Okay, then I think there are enough tough topics to discuss in the future. One we already hinted at about. This is the implementation variability, what you could do there. This is most interesting for us software engineers. Another hot topic would be
all the variability stuff. How do you describe variabilities and discuss more about feature modeling and these kinds of things? So before we finish this one, I kind of wanted to play devil's advocate and ask one question. That is, whenever I read about, talk about, or discuss about product line engineering, I kind of have the problem that I can't really touch it. There is no product line tool. So is it correct to say that product line engineering is more like a mindset and some guidelines for process and stuff, whereas if you want to really do it, you need a lot of things that that have that chip under different flags, like model-driven development, aspect orientation, feature modeling, frameworks, component-based development, whatever. So is if you talk about product line engineering, is the technology the problem, or is it really more a process, framework, and mindset kind of thing?
Well, yes, software product line engineering for me is also not really touchable. There is no tool. There are tools but they cover only partial aspects.
Right.
And there's a community. There's knowledge. There's books. There's experience. There's success stories. Yes, I think at the core it's a mindset. And what I also heard is, it's just software engineering done right. I mean, whatever you would do to succeed in your domain in successfully developing those multiple products. This is what I heard just somebody famous from the AOSD community say. And I was smiling, and I could just agree. Yes, I mean, there's nothing artificial. There's nothing so special about it. It's just a set of best practices. It's a set of principles. And what I actually strive to do is it's a set of patterns, I believe, coming back to our...
to Michael's famous topic.
Yeah, I believe you can derive some key principles in product line engineering, and you can derive some key patterns that describe the principles and make use of them so that it's truly applicable. And there's also not something like the product line engineering process. There are some techniques, there are some important process steps that you need to follow, and there is a certain requirement on the maturity that we didn't talk about the maturity of an organization.
Right. And also of a domain. If you don't understand your domain, it's probably not very feasible to come up with a product line approach for it.
Yeah, so there's no single process for it. So it's the same as with the agile methodologies, which is again another interesting topic. How to combine agile methodologies and product line engineering, really challenging again. Yeah. Today you have to read a lot of literature. You need to talk to people who did it, and you just need to try it and maybe make just a better platform and care about the platform, maintain it, think about the variability and things like that to do software product line engineering today.
Okay, and since we kind of agreed that product line engineering is this umbrella over some specialized, more specific techniques, we'll cover some of these specific techniques in subsequent episodes. Some of them we have already covered, model-driven development, and we'll cover others in the future. Anything else you want to say?
Thanks for listening.
Bye. Thanks for listening to Software Engineering Radio. If you want to get more information about Software Engineering Radio, or if you want to give us feedback, please go to our website at se-radio.net. You can also contact the team at team@se-radio.net, although we prefer entries in our comments system on the website so other people can see what you think. Software Engineering Radio wants to thank Henning Pauli for the intro and outro music, as well as Libsyn for providing the bandwidth. This episode of SE Radio, as well as all other episodes, is licensed under Creative Commons license. See the Software Engineering Radio website for details.